Hi, in this video, I'm going to talk about EIGRP for IPv6 and manual summarization. So here's our topology that we're using for EIGRP for IPv6. All the interfaces and EIGRP have already been pre-configured. And what we're going to do is we're going to summarize those 4 loopback addresses. Remember, loopback addresses are just for demonstration purposes, but we can use them for routing and pinging and all kinds of things. Okay, so what we've done is we've configured the 4 loopback addresses, as you see there, on router R3 for IPv6 and enabled those loopback interfaces for EIGRP for IPv6. Okay. So next, let's go ahead and configure manual route summarization. Okay. Similar to that of EIGRP for IPv4, we just say IPv6 summary address EIGRP, and of course we use IPv6 prefix and prefix length. Okay, so let's see how we summarize this. So let's say we have, so in this case, by the way, we have the 4 networks, so we're going to go ahead and summarize the 4. So just like we did for IPv4 addresses, we just going to find where the addresses differ. Now, we don't need to write this whole thing out in binary. Let's just write out where the addresses differ. Let's just write that portion out in binary, okay, or in hexadecimal. Okay, so here we've done it in hex, okay, and all right, we see where they differ. They differ on the, looks like the 4th hexadecimal, the rightmost hexadecimal digit. All right. So let's then just take that those 16 bits and we'll write them out in binary. So then now we can see much more clearly where they differ. Okay. So if we look at this, we look at that, it's the first 16, 16, 16. So these first 48 bits, they match no problem. Then where does the matching stop? And we go down each column here to find right here, 00001. That column doesn't match, but everything prior to that does. So that the first 13 bits of that hextet does match. So 16 plus 16 plus 16 plus 13 is /61. There's our prefix length. Okay. Next, all we have to do is add zeros to get the prefix, just like we did in IPv4. Take all the matching bits and then just add zeros. And here we just have to do a double colon at the end. Put 3 zeros to the end of that hextet and then a double 0. Okay, so what do we get for our summary address? 2001 DB8 ACAD double colon 61. Okay, so now let's go ahead and add that. Oh, I got /48s there. Why do I have /48s?